I am Anil Kumar sharing with you 4 questions from previous test papers on transformation of sinusoidal functions. Now all these questions are from IB grade 10 trigonometry. The questions are, first make a note of these questions and then we will see how to solve them. In the first question, we'll find amplitude, period, vertical translation and phase shift for each of the following functions. So we have 3 functions here, A, B, and C, right? In the second question, we need to sketch one cycle of the graph for each of the following function. So we have one in sine, another one in cosine. Then we'll talk about how to write equation for the given graph in the form y equals to a sine k x minus t plus c. Question number 4 is a word problem. An object suspended from a spring is oscillating up and down. The distance from the high point to the low point is 30 centimeters and the object takes 4 seconds to complete 5 cycles for the first few cycles. For the first few cycles, the distance from the mean position d of t with respect to time t seconds is modeled by a sine function. Write an equation that describes the distance of the object as a function of time. So I hope all the 4 questions are absolutely clear. They cover the whole chapter in great details and their solutions will help you prepare for your own test. Before answering, let me summarize the basic concepts which we have learned in this particular chapter about transformation of sinusoidal functions. So generally, we will be writing equations in the form of y equals to a sine k x minus d plus c, right? Now in this case, amplitude is a, so a is amplitude, which can be calculated if you know maximum and minimum values, right? So it is maximum minus minimum value divided by 2. C is, you can say axis, which is average value, which is maximum plus minimum divided by 2. So C will also be referred to as vertical translation. Okay. K is related with time period, right? So K is number of waves in one. K, I should write number of cycles in 360 degrees or 2 pi, depending on which units you are doing, right? Now K can be taken or calculated from 360 degrees divided by time period t, or if you're working in radians, then 2 pi by t, where t is time period. Now time period can be calculated as a distance between two consecutive maximums, right? Or it could be minimums also, whatever, right? So we are looking for 2 similar points basically, right? So maximums or minimum. If you are given just one maximum minimum, then that will be half the time period. Is it okay? So that is how we can calculate all of them. And D is referred to as phase shift. Phase shift actually says duration or time after which the wave starts. Right, so I'll explain more about phase shift as we take up examples. Correct? So now let us answer the questions. I hope these formulas and key things are absolutely clear to you. So we'll begin from the very first question now, which is regarding from the given equation, we have to calculate or figure out what is amplitude, what is period, what is vertical translation, and phase shift. So to answer this question, let me make a table here, and we'll just write down all the required parameters for each one of these functions, right? So let us say we'll write here, we want to know amplitude, so I'll write amplitude A, right? A for amplitude. Period, I'll write T for period, T, right? T for period. Vertical translation, let me write letter C for vertical translation. And phase shift, I'll write letter D for phase shift. So in general, whenever we talk about transformations, we are using a particular formula, which is, which let me write somewhere. Okay, so let me write here, the formula will be y equals to a sine, we'll write sine function, sine k times x minus d plus c, right? Now, A is the amplitude, so that is how you have to compare each equation. So A is the amplitude, T is the time period. I'll tell you how to calculate time period. Time period will be, it depends on which units you are working with. So I'll write down the formulas and then we'll figure it out. Okay, let me write down here. So time period will be 360 degrees divided by k, if you're working in degrees. And if you're working in radians, then it will be 2 pi divided by k. Is it okay? So that is the time period. The values of A, C, and D can be directly related from these equations, right? Not a problem at all. Okay, so let me just write these values. Let me make another column here. And I'll write down for each. So this is A for us, which is 3 sine x minus 5. So let's write down for 3 sine x minus 5 first. So for 3 sine x minus 5, you can directly read 3 as the amplitude. Now, nothing is written here, right? So by default, it will be taken as 1. So the time period will be 360 degrees, or you could say 2 pi radians, right? Depending on which units you are using. C, as you can see, is minus 5. So we'll write minus 5 here. And D, the phase shift, in this case is 0, since it is x minus nothing, right? So that is how you will get all these values for the first equation. Now let us take the next equation, which is 3 by 4 sine of half x minus pi by 6 minus 2, right? So 3 by 4 becomes the amplitude. So now the amplitude is 3 by 4. Time period will be, you have to divide 360 by half. So it becomes 360 times 2, right? So when you divide, it is like multiplied, right? So it is 720 degrees. In case you want to write in radians, then it is 2 pi divided by half, which we say is actually equals to 4 pi. Do you get it? So that is what time period is. C and D you can directly read. C is, as you compare here, axis. So C is minus 2. The wave goes 2 units down. And D is also called phase shift, which is pi by 6 to right. right? So let me write the alternate names here also. D is also called phase shift. And C is also called axis, right? A is amplitude. Okay, time period is T, right? Now let's get back to the last one here. I actually rewrote these mainly because of this particular equation. Now it's a good practice whenever you get the equation in this form to write it in general form, right? So we could write this as 3 times. So write amplitude first, sine. You have to factor 2 out. So we get 2 here. And then x, when you factor 2 out, you get 30 degrees. So that becomes the phase shift. Do you see that? And then plus 1. And now you can straight away write down the values. Amplitude is 3. Time period is half of 360. So it is 360 degrees divided by 2, which is equal to 180 degrees. Or you can say pi radians. Is it okay? Pi radians. As far as C, now you can see very clearly is 30 units. Well, if I write in degrees, you have to write everything in degrees. So 30 degrees to right. 1 is the axis, 1 unit up. Correct? So that is how you can actually read amplitude, time period, vertical translation, and phase shift from the given equation. Remember, for time period, we have to use the value of k. It is 360 divided by k or 2 pi divided by k, right? Question number 2. We need to sketch one cycle of the graph for each of the following. So first I have taken up a sine function whose amplitude is 3. Time period is, we'll talk about degrees, 360 divided by 2, which is 180. It is moved 30 units to the right and 1 unit down. Perfect. So that is how you could read all the information. Now let me show you how to sketch it. So let us say this is the mean axis, right? I will sketch it in 2 steps. So I'll follow 2 steps to sketch. Right, so I'll follow 2 sketch to sketch. In the first step, I'll not include phase shift, right? Only in second step, include phase shift. Okay, that will help you to easily sketch these functions. You can also do by transforming key points. You could do that. But I hope you like this method. It is very straightforward and simple. So first step is -1 is our translation, one unit down. So at -1, I will draw a line, which is the axis of the given equation. So this is at -1. Now, the amplitude is 3. That means from here, we should go 3 up, right? So it becomes kind of like this. So let me draw rough lines here. 3 up and 3 down, right? So 3 down will be, let me just extend this bit more. So 3 down will be kind of like this, right? So 1, 2, 3. 1, 2, 3 down. These are rough lines, okay? So that means the maximum is going to be -1 plus 3, which is going to be 2, and minimum is going to be -4. So you get amplitude of 3. Perfect. Now time period can be calculated from this value of k. So we know time period t is equal to 360 degrees divided by 2, which is 180 degrees. Perfect. Now sine wave can be sketched very easily from this by just connecting, like I'll just sketching this way. Was it okay? And then we'll make everything else later. So that is one wave. In this one wave, you can see that this point has to be 180 degrees. one wave. Do you understand? This is 0 for us, correct? So the maximum lies at 90. So the midpoint here, this midpoint will be at 90 degrees. This will be 45, 1/4, right? And this will be 45 times 3. 3 times 5 is 15, 135 degrees. So what we do here is, we take the time period, 180, and divide it into 4 quarters. Do you see? 1/4 is 45. So this point here is 180 divided by 4. This point here is 180 divided by 4 times 2. This point is 180 divided by 4 times 3. And this point is 180 divided by 4 times 4. That is 180 degrees. So time period is divided into 4 equal quarters to get your line. So this is my first step. The second step is to incorporate the phase shift. Now phase shift is 30 degrees right. Perfect. So this is first step. Second step is 30 degrees right. Phase shift. Clear? So 30 degrees for us will be, if I divide 90 into 3 equal parts, let's say these are my 3 equal parts, then that much is 30 degrees. So I move each point 30 degrees. So that much is 30 degrees. I move these points 30 degrees to the right. Do you see that? And once I have done so, I can combine them, join them with a smooth sinusoidal function, right? This point also 30 degrees. So this wave which I get, and of course the last point here will be 180 plus 30. So what is going to be this point? 180 plus 30 is 210 degrees. So this wave actually starts from 30 degrees and goes up to 210 degrees, which is being represented here as 3 sine 2x minus 30 degrees minus 1. Is that clear to you? So that is our final wave, right? So this is, in that color, is the final wave. Do you understand it? Perfect, right? Good. Now, next equation, I'd like you to pause the video, sketch the graph of this function, cosine function. But before that, let me rewrite this function, right? Let me rewrite this as we understand. So let me rewrite here itself. So we should actually write this as minus 3 cos of factor half. Otherwise, you might do a mistake. Factor half, we're getting x minus 90 degrees. Perfect. And then plus 1. Do you see that? So that is what your function b is. Now I hope it becomes simpler to sketch this function. As a part of an exercise, you should write the transformations first and then sketch. Okay, this time we are moving up, so I'll take my scale a bit down, right? So I'll sketch from here. Okay, so let's say this is our scale. We'll follow 2 steps. First step, axis. So first step is this. So we'll draw a line which is 1 unit above the x-axis, since we have translated the whole function 1 unit up. So this is y equals to 1. Is that okay? Amplitude is 3. So we go 3 more from here. So this is 1. So we go 1, 2, and 3. So that becomes the maximum. That is the maximum for us. Similarly, 1, 2, 3. That becomes the minimum for us. Is that okay? So this maximum is at, this is at 1, right? This is at 4. And this one is at minus 2. Our wave is within this. Now cosine function starts with maximum. Since it is negative, we'll start with minimum, right? So normally it will go like this. But since it is negative, we'll go like, not like this, but we'll reflect it. We'll go like this. Do you see that? Do you see that? So basically, we have 4 points to connect. So it'll go like from minimum to center, then top, then here, and then to minimum. Do you see that? So that is how your sine function will move. Correct? I hope that is absolutely clear. So I took these points very close. Let me just, okay, so I'll just make a sketch first and then we will connect, okay? So the function starts from here. So let me make this cosine wave. Those are, okay. Let's say these are my 4 points. Okay, that's okay. So what we have sketched here is everything but not this, minus 90 degrees, right? Now here, what is the time period? Can you tell me that? So time period here is degrees 360 divided by half, which means 720 degrees. Is it okay? So on this scale, I mean, this is this point, this is here, that is the center, and that is the end. So the end is at 720 degrees. Perfect. Now here we have 360 degrees. Half of 360 degrees is 180 degrees. We have a phase shift of 90, that means half of this. Do you see that much is 90? So every point moves by 90 degrees to the right, which is that much. So every point moves by 90 degrees to the right. Do you get the point? For the second wave, which is our final answer, is this cosine wave. So this cosine wave is the answer. So in the second step, we include the phase shift of 90 degrees to the right and then sketch it. So I hope that is absolutely clear. Now it's a good practice to write down starting and the final points. So starting point is from 90 degrees. So this wave is from 90 degrees to x value goes to 720 plus 90, which is 810 degrees. Is it okay? Plus 90, 810 degrees. So that becomes the domain of your one wave, and the range is from -2 to 4. At times, you may be asked for domain and range. So I hope that is clear. So as an exercise, what is the domain and range for this function? One cycle. Domain is from 30 degrees to 210 degrees, and the range is from -4 to 2. Perfect. So I hope that is absolutely clear. Now have a good view of this, and then let's move on to question number 3. Here is question number 3. The question is, write equation for the given graph in the form of y equals to a sine k x minus d plus c. Here is a graph given to us. You can actually pause the video, answer this question, and then look into my citations. A is the amplitude, which we can find from maximum and minimum value. So in such cases, we should first read what is given in the graph itself. So maximum is how much? That's the first thing which we should take care of. So maximum is at 3. Minimum value is what? Minimum value is -1. Once we get maximum and minimum value, we can find the vertical components, which are amplitude and vertical translation, right? So amplitude is basically maximum minus minimum divided by 2. C, which is vertical shift, is the average value of the graph, which is maximum plus minimum divided by 2, correct? Let's substitute these values. 3 minus -1, divided by 2, which means 4 over 2, which is 2. And here it will be 3 plus -1 divided by 2, which is 2 divided by 2, and that is 1. So once you get these values, it is a good practice to kind of sketch it, right? So C is this value for us. C is this value. So y equals to 1. And we know these are maximum and minimum values, correct? You can check from here that amplitude is 2, which is kind of correct. So we got the value of A as 2, value of C as 1, correct? Now let's go to inside the function, horizontal components. For inside, we have to look for k first, right? So what is k equals to? K is actually, we could write this equation in degrees or in radians. So let's write first in degrees. 360 degrees is normal cycle. Number of waves in 360 we need to count to get the value of K. So we can divide this by the time period T. So what we need to figure out is what is the time period. So let us first find what is T, right? So the time period. Time period is distance between two maximum or between two minimum. Is that okay? So you could do either, right? So here you can clearly see that the distance between two minimum is 2 units, right? That is 1 unit, so it is 2 units. 1 and 1, 2 units. So time period is 2. Since time period is 2, K can be written as 360 degrees divided by 2, which is 180 degrees. Is it okay? If you're working in radians, then it will be 2 pi by 2, or which is equals to pi radians. Is it okay? That will be the value of K if you write the equation in radians. Okay. So we know this. Now the last and most important here is to figure out how to do phase shift. Now this is the only question in which I am explaining how to see the phase shift from the diagram. So take it, try to understand it. So these are, let me just highlight since it is not clearly visible. So 1 is divided to 4 parts. And what we notice here is that the sine wave starts at quarter. This is 1/4. Do you see that? Starts at this point. So for phase shift, which is D, we always check from where the wave starts. So we can see that wave starts at 1/4. So sine wave starts at 1/4, and therefore the value of D is 1/4. You get an idea, right? So you could write in fractions, or you could write 0.25 as you wish. That's one and the same thing. So we got the value of D also. Now we can write down our function. So the sine wave could be written as y equals to A, amplitude is 2, sine of K value. If you write in degrees, it'd be 180. X phase shift is 1/4. You could write 1/4 or 0.25 as you wish. To the right, so it is 0.25. Let me write like this. And it moves up by 1 unit, so plus 1. Perfect. If you want to write the same equation in radians, or you can write this as y equals to 2 sine pi x minus 0.25 plus 1. Same, right? The only thing is degrees and radians. That's the only difference, correct? So this part is in degrees when you are considering 180 degrees. Perfect. So that is how you get your equation. Now let's move to the last part. I think it's absolutely clear. Feel free to write comments and share your views if you have any doubts. Okay, have a good look. The last question here is, an object suspended from a spring is oscillating up and down. The distance from the high point to the low point is 30 centimeters, and the object takes 4 seconds to complete 5 cycles. For the first few cycles, the distance from the mean position dt with respect to time t seconds is modeled by a sine function. Write an equation that describes the distance of the object as a function of time. So let us see what is really given to us, right? So, and then we'll develop this equation. So from this ceiling, we are given a spring, which is kind of like this. Let's attach a mass to this spring. Okay. So what is really happening here is that this object is oscillating. That means it goes up and it comes down. And this is the mean position, right? So this is the mean position. So as it goes up and down, I mean, it's oscillating at one point only. It just goes up and then comes down and then goes up. So that is kind of one cycle. It's a vertical cycle. However, time t moves, right? So if you see over the stretched time, kind of looking at where the position is, then you would think about the wave moving like this. Do you see that? Kind of like that. Is it okay? So you could see a wave moving like this. So what we are given here is that the distance from high point to the low point is 30 centimeters. So this distance from high to low, this distance is 30 centimeters. Is it okay? And it takes 4 seconds to complete 5 cycles. So it takes 4 seconds to complete 5 cycles. Is it okay? Now let me rewrite this sentence as 5 cycles in 4 seconds. We want to find time period. That means 1 cycle in how much? Of course, 4 seconds divided by 5. That becomes time for 1 cycle. Perfect. So if you want, you could write in decimals. 40 divided by 8, 5 is 0.8 seconds. You could do that. Or you could just keep it in fractions, 4/5. Perfect. Now, in this case, what are we asking for? For first few cycles, the distance from the mean position, dt. So this, from the mean position, the height from the mean is dt. That means distance, let me write like this, distance with time. So, is modeled by a sine wave. Write an equation that describes the distance as a function of time. Straightforward, right? So generally, we could always write this as a sine k x minus phase shift. We say normally use letter D plus c. Is that okay? Now, since we are saying that the distance is from the mean, c is 0, correct? A, the amplitude is distance, maximum you can go up. So 30 is total distance. This is total distance. Half of 30 is amplitude. So what is amplitude here? Amplitude is 30 divided by 2, which is 15, correct? The value of k will be, if you work in degrees, then be 360 divided by the time period. In our case, it will be 360 divided by time period is 4/5. Correct? That. So that means we can use a calculator, figure this out, right? So we have, 360 divided by, within brackets, 4 divided by 5. You could do that. Or you could write 360 times 5 divided by 4. Anyway, you get the value of k as 450. So if you want to write this, and c is 0, right? We know c equals to 0 since we are talking with respect to axis itself. And therefore, I could write this equation d of t as amplitude is 15 for me, right? Sine k value is 450. Now, x in our case is time t. So we'll write in terms of time t, right? Minus phase shift is 0, so just t. And plus 0, so that's it, right? So that's it. So that becomes the equation of this particular thing when you write in degrees. If you want to write in radians, well, in that case, k value will be, let me calculate for radians. In that case, k value, let me do it in different ink. So k will be 2 pi divided by 4 times 5, right? That is 5 pi by 2, right? So in that case, we could write this distance as 15 sine 5 pi by 2t. Is it okay? So that becomes in radians. And the earlier one is in degrees. So I hope these 4 questions help you to review what you have learned, consolidate for your test, and I hope you do well. Feel free to share your comments and views, and if you like and subscribe my videos, that'd be great. Thank you and all the best.